I am having doubt. I am not able to solve it.
Okay, fine. Just give me a second. I think my laptop got freezed. I'll
Okay.
just restart my laptop and please be in the meeting, all of you guys. Okay, don't leave the meeting. Be in the meeting.
Okay.
Yes. Who said who was having doubt? Amna or Zoha?
Amna.
Amna. Okay, fine. First question you said, no? Let's see the first question. Can you tell me what was the question, by the way? Can you read it, the first part? I don't remember
What are
actually.
the intensity and the wavelength of photon emitted during transition from n is equal to 2, n is equal to 2 state the hydrogen atom.
State in the hydrogen atom. Okay, fine. Can all of you see the screen now?
Yes, sir.
Okay. So in the last lecture, we saw that. See, this is a equation or a formula that you have to remember. Energy of nth orbital is equal to, if you are in first orbital or second orbital, then what is the energy of the electron? When you are in a certain orbital, it is equal to how much? Minus 13.6 into z square divided by n square, right? So what is the z here? Z is atomic number. Now it will depend, no? You are in hydrogen atom or helium atom, lithium atom, what atom you are present in, and divided by what orbital or what orbit are you going to check. You are in the first orbit or second orbit or third orbit, huh? You just need to plug in those values. Now, if I look at the question that was given in the homework, was this question: what is the frequency and wavelength of a photon emitted during transition from n is equal to 5 to n is equal to 2? Okay, so when you go from 5 to 2, there will be a photon emitted. and what will be the frequency and wavelength of that photon. So basically, you are first of all in which orbital? In initial is equal to how much? 5. And you are going to n final. Final is equal to how much? 2. Is that right, everyone? Yes or no? Please tell me.
Yes, sir.
Yes, sir. So now what here you have to do, if you want to see the change in energy, okay? So whatever there is a change, is there any change in energy? Yes, there will be a change in energy. What will be the change in energy? Please see. Initial minus final. So change in energy will be equal to energy in the final minus energy in initial. So what is the energy in the final? Energy in final is energy in the second subshell minus energy in the fifth subshell. Is this clear? Yes, please tell me.
Yes, sir.
Yes. Now for hydrogen atom, we have got the values of n, right? N is 5 and 2. Now the value of Z is equal to what for hydrogen atom? What is the atomic number of hydrogen atom? What is the atomic number? Yes, very good one. Now we are just going to plug in the values here. So for E2, it will be equal to minus 13.6 into 1 square divided by how much square? 2 square. This minus energy of fifth will be minus 13.6 into 1 square, that is the atomic number square, divided by 5 square. Is it clear? Yes or no? Please tell me, guys.
Yes, sir. Clear.
Now what will be the change in energy now? This will be equal to minus 13.6. I can take minus 13.6 common. So minus 13.6 is common in both the cases. Now here what is remaining? 1 by 4 minus here what is remaining? 1 by 25. Is this clear? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
Now what we need to do? Minus 13.6. This is just a fraction, right? 25 minus 4 divided by 25 4s are 100. Okay. So this will be equal to minus 13.6 multiplied by 25 minus 4. Abdul Hamid, can you speak something?
20.
Abdul Hamid?
Yes, sir.
Now you are audible. Okay. So minus 13.6 multiplied by 25 minus 4 will be equal to 21 divided by 100. Now, correct, guys? Yes or no? Please tell me. Correct, guys? Yes or no?
Yes,
No
sir.
problem.
Yes, sir.
You can just solve this now. What will be the answer? (13.6 into 21), it is equal to minus 285.6. Divided by 100 is as it is. So this will be equal to 2.856. Now, what will be the unit? Please see here, guys. What is the unit here? Kilojoule? Sorry, my bad. It is electron volts per atom, right? What is the unit here? Electron volts
Electron volts per atom.
per atom, right? So this will be electron volts. So in one atom, and it is electron volts per atom. Minus will be there here. Electron volts per atom. So what does this minus sign signifies? Minus sign is signifying that electron will be released. Okay. What is it signifying? It is signifying that a photon will be released. Photon will be emitted. If this was positive, then we would have said photon is absorbed. Photon is absorbed. Now this photon which is emitted, it is having energy how much? 2 point. Energy of photon emitted is equal to 2.856 electron volts. Is it clear? Yes or no? Please tell me, guys. Tell me. Are you having a doubt? Sir, minus कहाँ गया? Are you guys having a doubt?
Sir.
That sir, where is the minus sign? Hmm. Yes, Afan, Abdulhamid, tell me, guys.
No doubt.
Yeah. No, sir.
No doubt, right? There's a
No,
doubt.
sir.
Where
No,
is
sir.
no, no, because it is
No,
emitted.
sir.
Once the emission emitted, very good. So 2.856 electron volts. Now we have already seen this in the initial classes that E is equal to 1240 divided by lambda. Now this energy should be in electron volts and this lambda should be in nanometers. So I can plug these values here. So what is the lambda will be equal to what? Lambda will be equal to 1240 divided by whatever the energy is in the terms of electron volts. So lambda will be equal to 1240 divided by electron volts is 2.856. Okay, so whatever lambda this comes, whatever value this comes, this should be in nanometers. So we'll get the lambda from here. And what is frequency? What is frequency? Frequency and lambda, they are related by what term? Tell me, guys. Frequency is equal to C upon lambda, right?
Yes, sir.
So we can just write here frequency will be equal to C into 2.86856 divided by 1240. C is what? C is 3 into 10 to the power 8 meter per second. All of you got this? Yes or no? Please tell me.
Yes, sir.
Then
Yes,
you will
sir.
just you will see here that this is in nanometer. Okay, so you will convert this in nanometer also. Nano you have to write now. So nano you this will be 10 to the power minus 9. It will be here. So then you can write the frequency now. It will be 3 into 2.856 divided by 1240 into 10 to the power minus 9 will go there. 10 to the power 17 it will be, I think. Done everyone? Yes or no? Please tell me. Amna, understood this one?
Yes, sir.
Okay. Any other doubts? Should I move on? Yes or no? Please tell me.
Yes, sir.
Okay. Write the topic, de Broglie hypothesis. Those who are new, they will understand completely from this part. De Broglie hypothesis. Please write it aram se abhi. We will explain everything. Okay. So first of all, please write. It gives the wave nature of an electron. What does de Broglie hypothesis do? It gives the wave nature of electron. Explain. According to this hypothesis, any object which is in motion any object which is in motion will have a wave associated with it. Any object, it doesn't matter what object it is, it says that everything. This wave is called matter wave or de Broglie wave. Now we will also prove how anything which is in motion can have a wave. Okay, so we are also going to prove this. The proof is very simple, by the way. Please see, everyone. All of you know the famous equation of Einstein. Yes or no, please?
E equal to MC square, right?
What is the most famous equation of Einstein? Sorry, guys, I don't know what happened actually. All of you know about this equation. Have you seen this earlier? Heard about it? E is equal to mc square.
Yes, sir.
Yes, sir.
Right. It's a famous equation, right? And we also have seen, we are going to take this as 1. And according to Planck, in the 11th standard, we saw that according to Planck, E is equal to hc upon lambda. E is equal to hc upon lambda. This is my equation 2. So de Broglie came, he did not do anything. He just said that equation 1 is equal to equation 2 because both of them are giving energy. So from here, what we can write? We can write from equation 1 and 2. What you can prove? You can prove hc upon lambda will be equal to m into c square. Now, in order to simplify it a bit, I can cancel this square and this c, right? And I will be left with what I will be left with if I put this lambda there. So lambda will be equal to, this m will go down and c will also go down. So lambda will be equal to h upon mass into the velocity. Mass into the velocity of light. Now, this is for electrons. This is for electrons. Now, for any object with velocity v, for any object with velocity v, I can write the wavelength of that object will be equal to Planck's constant divided by mass into its velocity. Mass into its velocity. All of you understood this? Yes or no? Please tell me.
Yes, sir.
Okay.
Yes, sir. Understood.
Please write this down if you have not written this. Above this you have written, no? According to Einstein. Akib, what happened? You understood or not understood? Akib? अरे नो सर क्या नॉट अंडरस्टूड बोलिए या तो सी माइक ऑन करेंगे प्लीज आकिब कैन यू प्लीज टर्न योर माइक ऑन how will I explain then if you are not going to turn your mic on? Not having a mic, then you are not allowed in my class. You just need to turn your mic on. You can't turn your mic on. Get some help and turn your mic on. Get a earphone or something. Do anything and turn your mic on. How will I explain? ये भी नहीं पता चलेगा कि आपको समझ में क्या नहीं आया क्या आया. माइक ऑन कीजिए, उसके बाद ही एक्सप्लेन करेंगे हम. Otherwise, look at these equations. We have not done anything big here. Is equal to mc square is equal to hc upon lambda. Both of them are equal to energy. So I have equated 1 and 2. So equation 2 is hc upon lambda. Hc upon lambda is equal to mc square is equal to mc square. Now here we have mc square. Here we have c. So both of these c can be cancelled. Lambda will go there and mc will come down. So we will have h upon mc. Now this is for electrons which are having speed of light. But for any object with velocity v, we can write h upon m into v because c is the velocity of the electron. That's it. And now in detail, if you want, then you have to turn your mic on. Tell me what you did not understand, which part, which equation. Okay. So I hope everyone is done writing.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now, what is mass into velocity? Tell me, guys. Mass into velocity. Class 9th, may you have learned a concept. Yes, mass into velocity is. What is mass into velocity? I can't hear anyone. Apaf, are you saying something? आवाज ही नहीं आ रही किसी की.
Sir.
हाँ.
Acceleration.
Mass into velocity is. What, Abdul Hamid?
Acceleration.
Sir.
Acceleration नहीं, momentum. हाँ, इल्हाम.
A moment.
Momentum, है ना? Momentum. Okay. Now, do you guys know what is the relationship between momentum and kinetic energy? Momentum और kinetic energy में relation पता है आप लोगों को? नहीं पता है? See here, guys. See here. What is kinetic energy? Kinetic energy is equal to half mv square. It is equal to half mv square. So I will put this k on the LHS. I will get 2 times of kinetic energy is equal to what? It is equal to mv square. Now I will multiply mass on both sides. So I will get 2 into mass into kinetic energy is equal to mass into mass will be mass square and velocity square. Now I can write 2 into m into kinetic energy is equal to mv whole square. That means it is equal to momentum square. Now I can write root of 2 into mass into kinetic energy will be equal to momentum. So from here I can also write instead of momentum, Planck's constant divided by root over 2m kinetic energy is equal to lambda. Is this clear, guys? Yes or no? Please tell me.
Yes, sir.
Right next. If electron is accelerated by applying voltage V, then kinetic energy is equal to electron volts. Whatever voltage you apply on electron, that will be electron volts, and that will be the kinetic energy. So in that case, lambda or the wavelength will become h upon root over 2m whatever electron volts you have applied. Please write this down also. Now write a question. Please write. What will be wavelength of a ball? Of mass 0.1 kg, moving with a velocity of moving with a velocity of 10 meter per second. And they have given the value of h, Planck's constant, it is equal to 6.626 into 10 to the power minus 34 joule second. Okay. So what you need to do, you need to just apply this formula, nothing else. Wavelength they have asked, they have given the velocity, they have given the mass also. So formula will be lambda is equal to h upon mv. Please calculate the lambda.
सर मास की SI यूनिट ग्राम्स होता है ना?
नहीं, सी यहाँ पे जूल्स जो है ना उससे फर्क पड़ेगा. सी व्हाट इज 1 जूल? 1 जूल विल बी इक्वल टू kg मीटर स्क्वायर, सॉरी kg मीटर स्क्वायर पर सेकंड स्क्वायर. दिस इज 1 जूल, राइट? तो उस हिसाब से दिस इज फाइन.
ओके.
Is it kg meter per second square? I think it is kg meter per second square, 1 joule. I think yeah, kg meter per second square शायद यही है. क्यों बताया क्या है kg मीटर पर सेकंड स्क्वायर और kg मीटर पर सेकंड स्क्वायर क्या है? मीटर स्क्वायर और सेकंड स्क्वायर. लेट मी सी. लैम्डा विल बी इन मीटर. मीटर स्क्वायर होगा फिर आई थिंक, बिकॉज दिस शुड बी इन मीटर ना, तो 1 मीटर बचना चाहिए. यहाँ पे 1 मीटर होगा एंड वेलोसिटी में 1 मीटर और दोनों कैंसिल हो जाएगा. इट विल बी मीटर ओनली, मीटर स्क्वायर, सॉरी. लिख लीजिए. The calculation is very easy. आप कुछ मल्टीप्लाई नहीं कीजिए, everything will get cancelled. Okay, everything will get cancelled. So joule is kg meter square second per second square divided by mass is 0.1 kg. So that means I can write 1 by 10 kg multiplied by velocity is how much? 10 meter per second. Okay, 10 meter per second. This is joule और यहाँ पे एक और second है ना, this joule second. So there is one more second here. Joule is kg meter square second square minus 2 and there is one more second here. Okay, so now what we are going to do, 10 and 10 will get cancelled, right? Kg and kg gets cancelled. this second inverse will go above. It will become what? 6.626 into 10 to the power minus 34. First of all, let me cancel this 1 meter with this meter square. Now what will happen? This second inverse will go above. It will become second plus 1. No, this is second minus 2, and then you have a meter as a, and here you have second square. So both of these will cancel each other out, and your answer will be in terms of meters. So lambda will be equal to 6.626 into 10 to the power minus 34 meters. This is the wavelength. Got this? Is one of these? Tell me, guys, all of you.
Yes, sir.
Okay. Zoha, आपको आया? Zoha understood this?
Yes, sir.
Okay. Now, please see. So, what did de Broglie said? De Broglie said that each and every electron can be represented by a wave. Can be represented by a wave. And what did Bohr said? Bohr said that each and every electron is revolving in an orbit. It is revolving in an orbit. Now, if I draw the wave of an electron, you tell me what is more suitable. Let me just get up my image. Just a second, guys. If I draw the image, if I draw the wave of an electron, then tell me what do you think it is more possible, which seems more accurate? Do you think the electron will have a wave which is completely in phase? That means it is like a one spring which is having waves, or it will be broken spring? What do you guys think? Tell me. Should this be possible for an electron? If it is one electron, should this be possible that it is having out of phase? It is not one complete thing. It is having loose ends, right? Yes or no?
Yes, sir.
Right. So that is why de Broglie also said one more thing, that when we are drawing the wave of an electron, the wave of electron should be in phase. It cannot be out of phase. It cannot be out of phase. Right. The next point, you don't have to draw this. Right. The next point. Electron wave should be in same phase. Should be in same phase. Now, so let us draw some waves of electron. If I draw some waves of electron, they will look something like this. Okay. Now, what do you guys think? If I increase the size of the orbit, the number of troughs and crests, the size of wave will also increase. Yes or no? Please tell me, guys. If I increase the size of the orbit, the size of wave will also increase.
Yes, sir.
Correct, guys? And that is why this is what increasing number of orbits. Now, next point is, if I see this point and this point, then it is 1 lambda. If you have a wave, the top of two waves, the crest, these are no, this is what? This is 1 lambda. This is wavelength. Similarly, this crest and this crest will be one wavelength. From here to here. And there will be another wavelength from here to here, right? These two crests. So in total, we can say that it is made up of how many lambdas? Tell me, guys. This one is made up of 3 lambda. Can all of you see that? Please let me know if you are having any doubts.
Yes, sir.
When you have a wave, then from here to here, this is known as wavelength. Yes or no? You must have done this in your sound chapter, na? Previously also, those who are new.
Sound chapter deleted था for
Sound chapter.
us.
नहीं, उससे पहले 8th स्टैंडर्ड में 8 में अल्ट्रासाउंड तो पढ़ा है ना आप लोगों ने? अल्ट्रासाउंड, इंफ्रासाउंड।
लॉकडाउन में गया सर वहाँ पे।
लॉकडाउन में चला गया, अच्छा ठीक है। व्हाट अबाउट अदर्स? वेवलेंथ पता है सबको? नहीं पता? बताएं खुदेजा, आप बताएं वेवलेंथ पता है आपको कि नहीं पता है? खुदेजा?
Yes, sir.
खुदेजा, सॉरी, डू यू नो वेवलेंथ? यस और नो खुदेजा?
Yes, I know, sir.
यू नो ना? हाँ ठीक है, सबको कम से कम वेवलेंथ तो पता होगा, राइट? So here
Yes,
you can
sir.
see, right, here there are 3 wavelengths, right? In the first diagram that you are seeing, 3 wavelengths. And how many wavelengths in the second one? This is first, this is second, third, and fourth. Tell me, how many wavelengths in the second one?
4.
4 lambda. In the third one, we have 5 lambda, correct?
Yes.
And here we have 6 lambda,
6.
right? Now, also one more thing, if you see here, all of these wavelengths, all of these lambdas is nothing. Lambda is just length, है ना? तो अगर हम थोड़ा सा क्या करें, if I pull this string down a bit here, if I pull this string up a bit here, then you can see that these waves are nothing but circumference of the circle, circumference of the orbit. Correct? Yes or no?
Yes, sir.
Right. So what I can
get
say,
this point, sir.
you can do it. अच्छा, wait a second. ऐसे आराम से ना. See here, I am taking this part of the string, okay, and I am pulling this down and I am reaching it here. Similarly, I am taking this and I am pulling it up and keeping it here. And then similarly, इसको पकड़ के यहाँ नीचे खींच दिया, इसको पकड़ के यहाँ ऊपर खींच दिया. So you will get the circumference of the circle. Correct, guys? Yes or no? So
Yes. Yes, sir.
yes. Right? So what I can also write, and this lambda is what? It was the, if you see, this is completely 1 lambda, 2 lambda, 3 lambda. So I can also write this circumference 2 pi r is equal to 3 lambda. Yes or no?
Yes.
Now for this second structure, the 2 pi r, whatever the radius be, radius can increase or decrease, it will be equal to 4 lambda. And here the circumference will be equal to 5 lambda. And here the circumference will be equal
6
to
lambda.
6 lambda. So I can write circumference of an orbit circumference, FRENC, na? FRENC. Yeah. Circumference of an orbit is integral multiple of wavelength. Integral multiple पता है आप लोगों को? Do you know what is integral multiple?
No, sir.
इंटीग्रल मल्टीपल यानी इंटीजर से मल्टीप्लाई कर रहे हैं, 1 से 2 से 3 से 4 से 5 से. And as you can see, for any orbit, if you see, है ना, for any orbit, if you see, what is happening? It is either 3 lambda, 4 lambda, 5 lambda. 2.5 lambda कभी नहीं आएगा. Is that right? Yes or no? Please tell me, guys.
Yes.
Yes, sir.
So that's the only meaning, that it is not going to be a decimal. It is going to be integer 1, 2, 3, 4, and etc. Okay. So from here we can write 2 pi r. Depending on what shell you are, it will be equal to n lambda. It will be equal to n lambda, and n is any number 1, 2, 3, 4. Now, please see here, guys. Now, I can also write 2 pi r is equal to n, and lambda is what? H upon mv. We have just seen from de Broglie. H upon mv. Now further, if I shift mv on the LHS, I will get 2 pi r m into v is equal to nh. And from here, I will take mvr. mvr is equal to nh upon 2 pi. mvr is equal to nh upon 2 pi. Do you know what is mvr? What is mvr? Any idea? Have you done rotational motion in your physics chapters? Rotation? Rotation हुआ है अभी नहीं हुआ है? Tell me guys. Rotation
No, sir.
नहीं हुआ है. ठीक है, no problem. So mv is what? Momentum, right? But this is known as linear momentum. जब आप किसी को धक्का देते सीधा सीधा. So these are what? These are linear momentum. But if you are very much angry और आपको बहुत डांट मिली है तो जोर से आपने दरवाजा पटका. जब आपने जोर से दरवाजा पटका तो that will not be a linear motion, that will be a circular motion, right? The door has a circular motion.
Yes.
So in that case, you will get what? You will get angular momentum. So you have to multiply always with r also, radius also. Okay. So that is angular momentum. So mvr what? mvr is angular momentum. Angular momentum, it is equal to nh upon 2 pi. nh upon 2 pi. अब उसके बाद उन्होंने h upon 2 pi, h is also constant, 2 is also constant, pi is also constant, so then once again got another constant और उनका नाम उन्होंने रख दिया h cross. h cross क्या है? h cross is h upon 2 pi. चलिए please write this down if you have not written. आप ये जो हमने यहाँ पे इतने सारे ड्राइंग्स है ना, इनमें से आप कोई एक भी बना ले, काफी होगा आपके लिए. Whatever is easy for you guys, 3 lambda, 4 lambda, 5 lambda, 6 lambda, whatever is easy, please draw it and then write circumference of an orbit is integral multiple of wavelength. अगर आपने पहले लिख लिया तो डायग्राम बाद में बना ले, no issue in that, but write this down, let me know once you're done. तो देजा आपको समझ में आ रहा है?
Yes, sir.
थोड़ा सा आप कोशिश करें, है ना, बाकी लोगों से थोड़ा ज्यादा आपको एफर्ट लगाना पड़ेगा अभी क्योंकि आप थोड़ा बीच में आएंगे, बट समझ में आएगा इंशाल्लाह. ठीक है, लेट मी नो इफ यू हैव एनी डाउट्स. ओके, इफ यू गेट स्टक समवेयर.
Okay.
It is very important to revise all of these things, whatever you are learning. Okay, this is very new and I will not say it is easy. If you compare it with 10 standards, whatever you have learned in 10 standards, it's very hard. Now, कुछ यहाँ पे, I mean, it becomes mixture also. I mean, in 10th standard, everyone waits. कि अच्छा फिजिक्स का कोई चीज अगर केमिस्ट्री में आ रहा है तो केमिस्ट्री वाले वेट करेंगे इसमें, लेकिन आपने देखा अभी मैग्नेटिक मोमेंटम तुरंत आ गया ऊपर से ही. If you start with the physics first chapter, unit dimension and measurement, वहां पे क्या क्या नहीं आता है, सब कुछ आ जाता है, सारा फॉर्मूला आ जाता है वहां पे. MLT कर करके सारा फॉर्मूला आ जाता है. Yes or no guys? है ना, नहीं आता है? वहां शायद आपने एंगुलर मोमेंटम देखा होगा. अगर देखिएगा, you go and flip some pages of unit dimension and measurement physics, you will see angular momentum there. Okay, so I hope everyone is done by now. Now, what is this n here?
Yes, sir.
What is this n here? So according to de Broglie, sorry, first of all, according to Bohr, n is equal to shell number. Shell number or orbit number, this is according to Bohr. And n is equal to number of waves. This is according to de Broglie. Meaning, number of waves in nth shell will be equal to n. Will be equal to n. For example, if there is a simple question, how many waves are present in third orbit of hydrogen atom? Then the answer will be very easy. Answer will be 3 waves. Is everyone done? Yes or no? Please tell me.
Just a minute, sir.
Okay.
They're done.
Done? Okay, great. Now, let us see the next one. De Broglie waves is over. So now we have done a lot of things to understand the structure of atom. Yeah, Amna. Yes, Amna, tell me. Scroll up करने कह रहे थे आप? ठीक है.
Done, sir.
Done? Okay. Now, we have seen many things happening to a structure of atom. Many of you were with us from the starting. Whatever we did with the structure of atom, however we determined the position of nucleus and proton, then we embarked on a long journey in order to understand the position of electron. We did many things. We first of all understood whatever wave is and what is the relationship between frequency and wave. First of all, we learned about the different components and different things in a wave. We have frequency of a wave, we have wavelength of a wave, we have energy of a wave. Then we looked at the relationship between them, between frequency and wavelength and wave number. Then we looked at different types of electromagnetic waves and their properties. We looked at cosmic gamma, XUV, visible IMR. And after that, we performed photoelectric effect. A photoelectric effect gave an idea that the electrons in the outermost shell of the most loosely bound electrons, whatever it is, wherever it is, the most loosely bound electron, it has certain energy with itself. And from there, we understood the concept of orbit and shells. Like if I look at beryllium, the electron is nearer. That is why it is difficult to remove it. If I look at magnesium, it is a bit simpler, a bit easier to remove the electron from magnesium. So all of these things we looked in the photoelectric effect. Now, after photoelectric effect, we saw the Bohr's model, because Bohr, he got an idea of the model, the theory from whom? From photoelectric effect. And after that, we have just seen the de Broglie equation, how de Broglie equation and how de Broglie helped to understand the wave nature of electron. Now, another scientist was working on the similar concept. His name is Heisenberg. His name is Heisenberg. He thought about something. What did he think about? We will see that. So let us suppose here we now know that the electrons are in circular orbits, and they have certain energy with themselves. So we will draw a few orbits and we will try to make up an atom, and then we will understand what Heisenberg was saying. So I will draw certain orbits first of all. Here we have tiny nucleus. And let us suppose that we have a certain electron on this particular orbit. Okay. Now we are going to go towards a very easy question. How do you know something is somewhere? How do you locate something? Think about it. How do you locate something? कैसे locate करते हैं आप? Abdul Hamid, can you please turn your mic on?
Yes, sir.
Is there anything around your table or in your table?
Yeah.
Pencil box वगैरह तो सबके पास होगा, right? Whatever pouch you have or anything, all of you have that. Yes or no? Please tell me, guys.
Yes, sir. Yes, sir.
Amna, Akib, Khudeija, Zoha.
Yes, sir.
Pencil box or the pouch that you keep, है ना? That will be present, right? It
Yes,
is
sir.
in certain part of the table. Okay, it is in certain part of the table. How do you know that it is present there? कैसे पता कर सकते हैं आप? कोई आपसे पूछे, आप अभी उठ के चले गए, है ना? आपसे पूछे कि आपका पेंसिल बॉक्स कहाँ है, तो ऑल ऑफ यू विल से ना टेबल में. कैसे पता आपको टेबल में? कैसे पता? बहुत आसान सवाल है, बहुत आसान. लेकिन जवाब नहीं दे पाई आप. इतना आसान, वो सारा आसान सवाल हो जाए ना, जवाब नहीं आता है. कैसे पता? अब्दुल हमीद, अफाफ, आमना, सॉरी, अब्दुल हमीद व्हाट?
उधर रखा हुआ है इसलिए.
बताओ कैसे पता आपको कि रखा हुआ है वहां पे? कैसे पता आपको? कैसे पता?
रहा है, दिख रहा है.
हाँ, करेक्ट है. हाँ, दिख रहा है आपको, राइट? करेक्ट गाइस? यस और नो? प्लीज टेल मी.
Yes, sir.
है ना? क्या आंसर है इसका? कि वो चीज हमें दिख रही. सो इन ऑर्डर टू लोकेट समथिंग यू हैव टू सी इट. इज दैट राइट? यस और नो? प्लीज टेल मी गाइस. In order to locate something, we have to see it. Okay.
Okay.
Now, if I turn the, sorry, yes, Afaf, you're saying something?
No, sir.
Okay. If I turn the lights off, will you be able to locate anything?
No, sir.
No, sir.
No, right? Similarly, in order to locate an electron, I have to shine light. Yes or no? Please tell me, guys.
Yes.
Yes,
Now,
sir.
as soon as I will strike light upon electron, and please understand the mass of electron is very low, and light, it will possess some energy, and that energy will be equal to h into its frequency, and it will be directly proportional to its frequency. Now, as soon as this electron will get some energy, it will change its place and it can go to a higher energy orbital. It will go to a higher energy orbit. Yes or no? Please tell me. Correct, guys? Yes or no?
Yes, sir.
Or even if it does not, if it does not shift to any other orbit, at least its speed will increase. If you are giving some kind of energy to an electron, just understand that light is actually like pushing the electron. Yes or no? Right, guys? Yes or no?
Yes.
So what will happen as soon as you see, if you are trying to see an electron, you have to strike light. And as soon as you strike light, its speed increases. Yes or no, guys? Tell me, all of you. Correct? No doubt now.
Yes, sir.
That is
Yes.
Heisenberg uncertainty principle. What did Heisenberg say? Heisenberg said that we cannot, it is impossible, that it is impossible to determine the exact velocity and position of a moving electron simultaneously. All of you understood Heisenberg principle? Because as soon as you want to locate it, that means as soon as you want to determine its position, you have to strike light. And when you strike light, you know its position, but now its velocity has changed. Correct? Yes or no? Please tell me, guys.
Yes, sir.
Yes, sir.
So this is Heisenberg's principle. Okay, uncertainty principle. So you will write the topic. All of you understood? Yes or no? Please tell me.
So
Anyone?
last,
Yes. Sorry. Who was that?
so can you explain the last point again? The velocity one.
Okay. So you understand that striking light upon electron is just like pushing it,
Yes, sir.
right? So if you push something or someone, what will happen? Their speed will increase, right? Or at least it
Yes.
will change. Correct?
Yes,
That's
sir.
it. Got it?
Yes, sir.
Okay. So please write Heisenberg uncertainty principle. तो दीजिए आपको समझ में आया? You understood this part? Heisenberg uncertainty principle, yes or no?
Yes, sir.
Okay, very good. Please write, it is impossible to determine. What does it say? It is impossible to determine the exact velocity and position of moving electron simultaneously. All of you done? Yes or no? Please tell me.
Sir, 1 minute.
Okay.
Yes, sir.
Now, please here, guys. If we cannot, if there is some uncertainty को कैसे लिखते हैं? Delta से? Yes or no? I hope you remember this from unit dimension
Yes,
and
sir.
measurement, right? Delta,
Yes.
right? So we have uncertainty in position or error in position. Error in position, error or uncertainty. In position, this will be equal to delta x, है ना? Position के लिए x यूज करते हैं. Similarly, error or uncertainty in velocity will be given by delta v. अब इसके बाद जो नेक्स्ट पार्ट है, अफसोस के साथ उसका प्रूफ आप लोगों को नहीं पढ़ना है ना. प्रूफ पढ़ना रहता तो मजा तो आता, लेकिन टाइम बढ़ा जाता ना. बीएससी और एमएससी में हम लोग को पढ़ना रहता है, तो उसमें मतलब ये प्रूफ आ जाता, तो फिर हम लोग एग्जाम में समझते हैं कि हमारा 3 पेज 4 पेज खत्म हो गया. व्हाट इज द uncertainty principle? It says that the uncertainty in position and uncertainty multiplied by uncertainty in velocity will be always greater than or equal to h upon 4 pi m. H upon 4 pi m. And if I shift this m into velocity, then I can write delta x multiplied by delta, sorry, m into delta v. This will be greater than or equal to h upon 4 pi. h upon 4 pi, है ना? h upon 4 pi. So what is p into m delta v? This is nothing but uncertainty in mv. क्या होता है? Momentum. So I can also write that delta x multiplied by delta p is greater than or equal to h upon 4 pi. Is this clear? Yes or no? Please tell me, guys. You have to learn this one. Important है आपके लिए. And also this one. Please write this down. Let me know once you're done.
Done, sir.
No, sir, 1 minute.
Okay.
Done.
Okay. So यहाँ पे जनरली आपको ना ये जो मास है, this is mass of electron. So if you have some space साइड में, तो साइड में लिख लीजिएगा मास ऑफ इलेक्ट्रॉन. वैसे तो स्टार्टिंग में बहुत सारे लोगों को लिखाया हुआ है हमने. मास ऑफ इलेक्ट्रॉन इज इक्वल टू हाउ मच? टेल मी गाइस. 9 into 10 to the power -31 kg. ठीक है ना? तो कभी कभी ये डेटा आपको मिला रहेगा, कभी कभी नहीं मिला रहेगा. और खास तौर से इफ यू सी द बिगेस्ट प्रॉब्लम इन एनसीईआरटी क्वेश्चन इज दैट एनसीईआरटी को लगता है कि जब आप क्वेश्चन कर रहे हैं तो आपके पास तो एनसीईआरटी बुक है, तो आप एनसीईआरटी बुक के आगे पीछे दाएं बाएं कहीं से भी वैल्यू आप निकाल सकते हैं, ठीक है। दैट इज वाई वो कोई भी कांस्टेंट का वैल्यू देता ही नहीं है, and this will be a major problem if you come in 12th standard. 12th standard, what will happen if you look at the question in the board में सारे सवालों में they will give, for example, if they give urea, so they will give you the mass of urea. If they give H2SO4, they will give the molar mass of H2SO4 also, ठीक है। but NCERT कहीं पे नहीं देता, NCERT never gives the molar mass of anything. तो उसमें बच्चों को लगता है कि सब कुछ याद करना पड़ेगा, नहीं सब कुछ याद करना जरूरी नहीं है, ठीक है। so for example, mass of electron in NCERT they will not give you. Why? Because if you have NCERT textbook, तब तो आप आगे पीछे देख के निकाल सकते हैं ना mass of electron. In the end you will have appendix. In appendix there has been all the constant has been given. देखिए तो सर लास्ट में है ना शायद. Look in your textbook if you have it right now. Let me also see. I have it, but it is in parts. So class 11th.
Sir, which page number?
पेज नंबर हमको नहीं पता, नया बुक है पुराना बुक है?
सर नया वाला.
रैशनलाइज लिखा हुआ है नीचे.
Sir, it starts from 243.
243 में है, इसमें है कुछ कांस्टेंट्स वगैरह हैं. इंडेक्स है यहाँ पे, तो आप
240 पे सारे मोलर मास.
सारे मोलर मास है ना, और कुछ कांस्टेंट्स वगैरह भी होंगे कहीं ना कहीं, तो मास ऑफ इलेक्ट्रॉन वगैरह भी होगा. देखने दीजिए मुझे.
Yes sir, 242 पे कांस्टेंट्स.
कांस्टेंट्स है ना, तो वही ये आप समझ लीजिए, जब आप एनसीईआरटी करते हो तो आपको ये दिक्कत आती होगी कि मतलब इतना ऐसी ऐसी चीजें भी, मतलब कांस्टेंट ये बोलता है कि हमको पता रहना चाहिए, इसके वैल्यूज बिल्कुल अजीब अजीब है ना. सो द ओनली रीजन इज दैट बिकॉज एनसीईआरटी मानता है कि एनसीईआरटी बुक है, तो देख लो भाई पीछे, ठीक है. So elements and their atomic number is there in 240 page मेरे किताब में, and then specific, this is molar heat capacities of some substances is there. ये आपको थर्मोडाइनमिक्स में काम आएगा. फिजिकल कांस्टेंट्स है यहाँ पे. सो मास ऑफ इलेक्ट्रॉन दिखा सबको? मास ऑफ इलेक्ट्रॉन दिया है नहीं दिया है? नहीं दिया है क्या? एटॉमिक मास, एवोगैड्रो कांस्टेंट, बोर रेडियस, बोल्ट्जमैन कांस्टेंट, चार्ज टू मास रेशियो, इलेक्ट्रॉनिक चार्ज, इलेक्ट्रॉनिक, हाँ मास दिया ना, देखिए इलेक्ट्रॉन रेस्ट मास दिया है, देखिए 9 एसआई यूनिट में, देखिए 9.10952 इंटू 10 टू दी पावर -31 kg. इलेक्ट्रॉनिक चार्ज के नीचे देखिएगा, नहीं मिला? मिला या नहीं मिला? हाँ बच्चों, मिला?
नहीं सर.
नहीं मिला?
नहीं.
कौन से पेज में आप? फिजिकल कांस्टेंट्स, फिजिकल कांस्टेंट्स में ही है ना मेरे में. दिस इज इन 242 पेज. How many of you guys are in physical constant page?
हाँ सर मिला. 9.10952 into 10 to the power
हाँ,
-31 kg.
है ना. तो वही क्या याद रखेंगे हम लोग बस याद रखेंगे 9 into 10 to the power -31 kg. That's enough for us. Okay.
Okay.
So mass of electron. चलिए. So we'll do a question from this Heisenberg uncertainty principle. Please write a question. A microscope using suitable photons using suitable photons. Photons क्या हो गया? लाइट ही हो गया, है ना. Is employed to locate
Yes,
an
sir.
electron. Is employed to locate an electron in an atom within distance, in an atom within distance of 0.1 angstrom. What is the uncertainty? What is the uncertainty? What is the uncertainty involved in measurement of its velocity? ठीक है, देखिए, see here guys. So it is saying a microscope using suitable photon is employed to locate an electron in an atom within the distance. क्या मतलब हुआ कि the whatever you locate, wherever you locate the electron, it should be within the distance of 0.1 angstrom. That means the error is 0.1 angstrom. Error कितना है यहाँ पे? 0.1 angstrom. So delta x is equal to how much in position? 0.1 angstrom, which will be equal to 0.1 into 10 to the power minus 10 meters. And they're asking what is the uncertainty in velocity. So we'll apply the Heisenberg uncertainty principle. I will write delta x multiplied by delta v will be equal to h upon 4 pi m. है ना? अब बोलेंगे सर ग्रेटर लेना चाहिए ना, ग्रेटर भी तो ले सकते हैं. नहीं, ग्रेटर तो पता नहीं कितना ग्रेटर हो जाए. We don't know what will be the value na greater ka. So at least this much will be the uncertainty we can say in velocity, right? At least कितना हो सकता है जो भी equal के terms में आ जाए. So I can write also delta v will be equal to h upon 4 pi m into delta x. Now I will plug in the values. So h is 6.626. We have given this value earlier, 10 to the power minus 34. This will be in terms of what? This will be in terms of joule per second. After, if you want to write the complete units, then you can write it kg meter square. Then what you are going to write? You are going to write second square. Sorry, second minus 2. This is joule, and then 1 second here divided by 4 into I is equal to how much? 3.14 or 22 by 7, whatever you want to take. 22 by 7, let us take, multiplied by m. Mass of electron is 9 into 10 to the power minus 31 kg. Multiplies by delta x. Delta x is equal to 0.1 into, ये कितना इसको लिख सकते हैं? 10 to the power minus 11 लिख सकते हैं meters. This will be 10 to the power minus 11 meters. ठीक है. अब यहाँ पे first of all units को खत्म करें, है ना? तो kg से kg कट गया. And meter से this meter will get cancelled, right? 1 meter get cancelled. And इस second से second inverse, second minus 2 था, second inverse हो जाएगा, minus 1 हो जाएगा. So as you can see, what is the unit remaining? It is meter per second, which is very correct because हमको velocity में निकालना है ना error. So that will be also in meter per second. Now let us separate that powers of 10 and the numbers. So it will be 6.626 and this 7 is denominator of denominator, so it will become numerator. Into 7 divided by 4 into 22 into 9 multiplied by, now powers of 10, 10 to the power minus 34. This minus will become plus, so plus 31. This minus 11 will become plus, so plus 11. All of you understood till here? Yes or no? Please tell me, guys. समझ आया नहीं आया? बोलें please. All of you understood this? Yes or no?
Yes, sir.
If you guys have any doubt, please let me know. ठीक है? So the sequence that I follow and I also ask my students to follow is, first of all, solve units. When you will solve units, ना तब आपको पता चल जाएगा कि आप सही जा रहे हैं या नहीं जा रहे. So I got meter per second, so I'm going to write. Then you have to solve the powers of 10. Powers of 10. After that, you have to solve what? After that, you have to solve the numbers. So let us see what is this value coming out to be. अब देखिए थोड़ा सा ना हम अप्रोक्सीमेशन करते हैं. देखते कैसे जाता है, क्या आता है। 6 को हमने थोड़ा घटा दिया, 6 कर लिया, ठीक है, और इंटू 7 कर लिया हमने, डिवाइड बाई 4 इंटू 22 को भी घटा दिया, 6 को घटाया तो 22 को भी घटा दिया, 21 कर लिया हमने, इंटू 9, तो 7 3 जा 21 हो गया, एंड 3 2 जा आपके पास क्या हो गया 6 हो गया, एंड 2 4 जा आपके पास 8 हो गया, इंटू 10 टू दी पावर कितना था बताइए तो जरा, -34 प्लस 31 प्लस 11, दिस विल बी इक्वल टू 10 टू दी पावर 8 आ रहा है, कोई कंफर्म कर लेगा प्लीज, ठीक है। एंड व्हाट आई एम गेटिंग, दिस इज इक्वल टू 1/18 आ रहा है हमारे पास, राइट, एवरीथिंग इन द न्यूमरेटर हैज बीन कैंसिल, 1/18 इंटू 10 टू दी पावर 8 मीटर पर सेकेंड।
Yes, sir, 8 times.
8 है, ठीक है।
Yes.
अच्छा 1/18 कितना हो जाएगा बताएं, 1/18 will be equal to how much? Any idea? If you calculate 1/18, it will be equal to 0.055. 0.5555 इस तरह से ये ज्यादा जाएगा, ठीक है, इंटू 10 टू दी पावर 8 मीटर पर सेकेंड। दिस विल बी इक्वल टू 5.56 कर सकते हैं, है ना, 2 डेसिमल प्लेस, 10 टू दी पावर 6 मीटर पर सेकेंड। अच्छा, एक तो हमारे ये अप्रोक्सीमेशन से आया आंसर आया है ना। नाउ लेट अस सी इफ आई कैलकुलेटेड इट एक्यूरेटली तो कितना आंसर आता। सो 6.626 मल्टीप्लाइड बाई 7, है ना, डिवाइड बाई 4 इंटू 22 इंटू 9। हाँ, तो इसमें आपके पास आंसर आ रहा है इसमें आ रहा है 5.8 इंटू 10 टू दी पावर 6। काफी नजदीक है, बहुत ज्यादा फर्क तो नहीं है ना। सो समटाइम्स यू जस्ट नीड टू अप्रोक्सीमेट, थोड़ा सा अप्रोक्सीमेट करके नियर बाई आंसर आप ले आइए। मोस्ट ऑफ द आंसर दे विल हैव, यूनिट आपका सही रहना चाहिए, पावर ऑफ 10 आपका सही रहना चाहिए, एंड इसमें आपके पास थोड़ा सा एरर हो सकता है, ठीक है, स्लाइट एरर इज पॉसिबल हियर। 11th-12th में कैलकुलेशन करने के लिए नहीं बुलाया गया आपका ना, कंसेप्ट समझने के लिए, एंड यू हैव आल्सो बीन आर बीइंग प्रिपेयर्ड टू गेस द आंसर्स, है ना, कि कैसे हम अप्रोक्सीमेट करें तो आंसर हमारे पास जल्दी आ जाए। इज इट क्लियर? यस और नो प्लीज टेल मी गाइस यहां तक।
Yes, sir.
है ना, सो यू कैन राइट अनसर्टेनिटी इन वेलोसिटी इज इक्वल टू uncertainty in velocity is equal to how much? It is equal to 5.56 into 10 to the power 6 मीटर पर सेकंड, ठीक है। एक ये थोड़ा सजेशन है आप सभी के लिए, जैसे जनरली बच्चे क्या करते हैं ना, ये इतना सारा सॉल्व करेंगे, उसके बाद ये आखिरी लाइन नहीं लिखते हैं, ठीक है। आप थोड़ा सोचिए इस बारे में। उन्होंने पूछा क्या है, व्हाट इज द अनसर्टेनिटी इन्वॉल्व इन मेजरमेंट ऑफ इट्स वेलोसिटी, ठीक है। मान लीजिए आपके यहाँ कोई मेहमान आया है ना, मेहमान आया और आपने क्या किया, उनको रूह अफ़ज़ा चाहिए, जैसे मान लीजिए रूह अफ़ज़ा जानते हैं सबको, ऑल ऑफ यू नो व्हाट इज रूह अफ़ज़ा, राइट, यस और नो।
Yes.
Yes,
तो
sir.
आप उनको किचन में बोला कि ये क्या हुआ, ये तो रूह अफ़ज़ा बनाना हो गया ना, करेक्ट है ना। ये हम बोल सकते हैं ना, व्हाट एवर यू आर डूइंग हियर रूह अफ़ज़ा बनाने के बराबर है, यस और नो। मतलब रूह अफ़ज़ा बनाने का मतलब यू आर
Yes, sir.
डूइंग समथिंग, है ना। ये उसको रूह अफ़ज़ा आप कैसे बना रहे हो उससे उतना मतलब नहीं है। इवन दो इफ यू राइट ऑल ऑफ दीज थिंग्स दे विल गिव यू मार्क्स फॉर दी स्टेप्स, है ना, तो आपको हाँ शाबाशी देंगे, चलो ठीक है रूह अफ़ज़ा तो ठीक नहीं बनाया, चलो कोशिश तो किया बच्चा, है ना। जब बच्चे ने कोशिश करके रूह अफ़ज़ा बना लिया तो अच्छे से उसको ट्रे में पेश करना भी तो है। यू विल प्रेजेंट इट इन अ वेरी ब्यूटीफुल वे ना, ऐसे ट्रे में ऐसे ग्लास में लेके तो नहीं जाएंगे आप, अम्मा मारेगी आपकी, है ना। सिखाया होगा ना सबको घर में, ट्रे में लाके देना है, कोई भी पानी की ग्लास लाके दे रहा है, रूह अफ़ज़ा लाके दे रहा है, कैसे देना है बताइए, नहीं सिखाया। हाँ अब्दुल हमीद, कैसे देते हैं बताइए, रूह अफ़ज़ा वगैरह देना रहता है तो किसी मेहमान को ट्रे में देते हैं या ऐसे ही हाथ में पकड़ा देते हैं?
Train.
ट्रे में ले जाके देते हैं ना। चाय वाय देना रहता है तो क्या वैसे प्याली पकड़ा दिया बस, जैसे होटल होटल में जाते तो छोटू पकड़ा देता होगा चाय, वैसे नहीं पकड़ाते ना, ट्रे में लेके जाते हैं। ऐसा नो ऑल ऑफ यू, आमना, आकिब,
Yes, yes.
इल्हाम, खुदेजा,
Yes, sir.
उसी तरह से
Yes, sir.
बिल्कुल ट्रे में ऐसे आपको जब सवाल दिया क्वेश्चन ने ना एग्जाम में, आप बिल्कुल ट्रे में ऐसे परोसे, है ना, ऐसे ट्रे में परोसिए क्या आंसर, ये लीजिए सर, ये है आंसर। बात समझ में आ रही सबको, हाँ या ना? अरे
Yes,
बोलो
sir.
भाई, थैंक यू वेरी मच।
Yes,
तो
sir.
घर में कुछ आपके एटिकेट्स आपके अम्मी ने सिखाया, और एग्जाम में आंसर लिखने के टिकट हम सिखा देंगे। चलिए, राइट, नेक्स्ट। अब यहां से जो पोर्शन है दैट इज वेव मैकेनिकल मॉडल ऑफ एटम और श्रोडिंगर वेव इक्वेशन, इसके बारे में थोड़ा सा आपको जानना है, ठीक है, बिल्कुल थोड़ा सा जानना है, कुछ ज्यादा आपको यहाँ पे नहीं जानना है, प्लीज, राइट। वेव मैकेनिकल मॉडल और श्रोडिंगर्स वेव इक्वेशन। Now, this Schrodinger wave equation or the wave mechanical model was introduced by Schrodinger, Erwin Schrodinger, and it was what was taken into consideration: the de Broglie, matter wave, Heisenberg uncertainty principle. All of these things were taken into consideration, and this particular thing was introduced. What does it do? It does the same thing what each and every other model is doing. It is going to tell you about the position of nucleus, तो सबको पता चल गया था after the alpha foil experiment by Rutherford, है ना, कि nucleus is present in the center of an atom. And this is going to tell you about the position of an electron. सारे बोर का भी क्या बोल रहा था, position of electron कहाँ पे है. Schrodinger is also going to tell you about the position of electron, but it is going to take into the consideration the wave associated with the electron. Okay, please write. This model gives the idea of wave associated with electron is right. The electron wave is described by following equation, is described by the following equation: d square psi divided by dx square plus d square psi, सॉरी ये पार्शियल डिफरेंशियल हो जाएगा, इसको d ऐसे प्रॉपर लिखना पड़ेगा, d square psi divided by dy square plus d square psi divided by dz square plus 8 pi square m into e minus v psi is equal to 0. ठीक है, घबराने वाली कोई बात नहीं, ना आपको इक्वेशन याद करना, ना आपके इक्वेशन ये आने वाला है, बस थोड़ा सा समझने की कोशिश करेंगे, है ना, कि ये क्या दे दिया भाई श्रोडिंगर ने, ये दे क्या दिया, तो बहुत ज्यादा टफ नहीं, आप लोगों ने डिफरेंशिएशन ऑल ऑफ यू मस्ट हैव लर्नड इट थोड़ा थोड़ा.
1 minute.
ओके, all of you have learned this, all of you have learned now the differentiation, yes or no?
Yes, sir.
है ना, you must have done equations of motions, right?
Yes, sir.
इक्वेशन ऑफ मोशन को डिफरेंशिएशन से सॉल्व करना रहता है ना, इंटीग्रेशन डिफरेंशिएशन लगा के प्रूव करना रहता है, राइट? वो तो क्या होगा आप लोगों ने फिजिक्स में, तो ये डिफरेंशिएशन है ना, तो इसका ये डबल डिफरेंशिएशन, किसी एक चीज को दो बार डिफरेंशिएट कर दिया, ठीक है, जैसे फॉर एग्जांपल इफ यू हैव टी क्यूब, तो टी क्यूब का डिफरेंशिएशन कितना होगा, 2t 3t स्क्वायर कितना होगा, 3t स्क्वायर होगा ना, 3t स्क्वायर 2t स्क्वायर कितना होगा, टी क्यूब का, टी क्यूब का डिफरेंशिएशन भाई लोग 3t स्क्वायर ना, सही कह रहे हैं हम? नहीं, हाय हाय, किसी का मैथ्स नहीं है क्या? ठीक लिखा हमने, पावर रूल ऑफ डेरिवेटिव तो यही होता है ना, सही लिखा हमने, ठीक है। तो आपने एक बार डिफरेंशिएट किया, क्या मिल गया आपको 3t²। अब इसको फिर से डिफरेंशिएट कर दीजिए, तो क्या मिल जाएगा आपको 3 × 2 = 6t। ऑल ऑफ यू अंडरस्टूड डबल डिफरेंशिएशन क्या होता है? अरे बोलो भाई, अब्दुल
Yes, sir,
हमीद,
understood.
अफाफ, है ना, ठीक है। तो दिस इज डबल डिफरेंशिएशन होगी। अब यहाँ पे जो एक्स वाई जेड है, दीज आर दी कोऑर्डिनेट्स। क्या ये एक्स वाई जेड कोऑर्डिनेट्स? साई, दिस साइन इज नोन एज साई, पी एस वाई लिखते हैं इसको, सॉरी पी एस वाई नहीं, पी एस आई। साई, साई क्या बताता है? वेव फंक्शन। किसका वेव फंक्शन? इलेक्ट्रॉन का वेव फंक्शन। फॉर एग्जाम्पल, जैसे साइन थीटा होता है ना, आप लोगों ने अभी शायद पढ़ लिया होगा कि साइन थीटा कैसे दिखता है, ऐसे दिखता है। कॉस थीटा कैसे दिखता है? पढ़ा नहीं पढ़ा आप लोगों ने?
No, sir. Graph
No,
नहीं पढ़ा.
ग्राफ नहीं पढ़ा है आप लोगों ने?
no,
सुनिए
नहीं.
no, sir.
अच्छा ठीक है, देखिए बहुत आसान है, कुछ ज्यादा हार्ड नहीं। आप लोगों ने ये पढ़ा कि रेडियन वाला पढ़ा, रेडियन एंड डिग्री, कि 1 पाई = 180 डिग्री, ये पढ़ा आप लोगों ने? नहीं पढ़ा?
नहीं, sir.
No, sir. Yes, sir.
नहीं, यस सर, नो सर, चलिए ठीक है। सुन, ये आपके पास 90 डिग्री है, ठीक है। तो साइन 0 0
Yes, sir.
धीरे 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 ये बढ़ता है और 90 पे क्या हो जाता है? 1 हो जाता है, ठीक है। और फिर 90 से नीचे आएगा ना, 90 के आगे फिर घटेगा घटेगा घटेगा, फिर माइनस में चला जाएगा। फिर ये आपके पास 180 में फिर से 0 हो जाता है ये। फिर ये आता है 270 में, 270 होता है ना बीच में, 270 होता है। फिर ये हो जाएगा -1, फिर धीरे धीरे बढ़ेगा। वही कॉस जो होता है, कॉस 0 कितना होता है? 1 होता है, ठीक है। पता है ना ये सारी चीजें, cos 0 1 होता है, हाँ या ना, 10th में तो पढ़ा होगा cos 0 1 होता है। हाँ तो वही
Yes.
वेव, हाँ तो यही सारे क्या है? वेव्स हैं। तो साइन थीटा का वेव बन सकता है, उसी तरह cos थीटा का वेव बन सकता है। तो उसी तरह के कुछ फंक्शन होगा दैट विल डिस्क्राइब द इलेक्ट्रॉन, किसको डिस्क्राइब देगा? इलेक्ट्रॉन को। एंड व्हाट इज देन, यही साई होता है, ठीक है। नाउ व्हाट इज दिस ई? ई इज द टोटल एनर्जी ऑफ इलेक्ट्रॉन, टोटल एनर्जी ऑफ इलेक्ट्रॉन। देन वी हैव वी, वी कुछ नहीं, पोटेंशियल एनर्जी ऑफ इलेक्ट्रॉन। टोटल एनर्जी में से पोटेंशियल एनर्जी माइनस कर दीजिए, काइनेटिक एनर्जी मिल जाएगा ना। तो कुछ ज्यादा नहीं है यहाँ पे, मूवमेंट को छोड़ने के लिए काइनेटिक एनर्जी को ऐसे रखा गया है। All of you got this question, please tell me. लिख लिया सबने? अब सुनिए यहाँ पे, नेक्स्ट psi is the amplitude of electron wave. That is the amplitude of electron wave. Therefore, it has no physical significance. Right, next. Since amplitude square is equal to, or rather, I should say, is directly proportional to intensity, is directly proportional to intensity. Therefore, I can write psi किसको बताता है? एम्पलीट्यूड को बताता है, ठीक है। और आप यहाँ पे क्या लिख सकते हैं कि एम्पलीट्यूड स्क्वायर किसको बताता है? इंटेंसिटी को बताता है। देयरफॉर साई स्क्वायर किसको बताएगा? ये भी इंटेंसिटी को बताएगा। व्हाट इज द मीनिंग ऑफ दिस? द मीनिंग ऑफ दिस इज psi square gives the idea of probability of finding electron probability of finding electron per unit volume Therefore, it has physical significance. Right, next. Psi square is AKA. AKA matlab also known as probability density. Yeah.